And welcome back. As we continue our cosmic journey through our own solar system, let's go ahead and shift our discussion now to looking at the nearest planets around us, which is that of Venus and Mars. So our closest neighbors in our solar system are, of course, Venus and Mars. Mars and Venus are also among the brightest objects in the night sky that we can observe. In fact, we can see them very easily even with the naked eye. Now, the average distance of Mars from the Sun is 227 million kilometers, or 1.52 AUs. Venus's orbit is very nuclear circular at a distance of 108 million kilometers, or 0.7 AUs from the Sun. Now, Mercury and Venus sometimes appear as an evening star or a morning star. It's a lot of times when you can see them because of their proximity along the ecliptic. Now, Venus will approach Earth much more closely than any other planet. In fact, the distance between them is quite unique. It's only 40 million kilometers from us at the nearest within the orbits. Mars, on the other hand, the closest ever it gets is about 56 million kilometers. So if we want to look at which planet is closer, Venus is going to be the answer. Now, let's talk about the appearance of Venus. Venus appears to be very bright, and even a small telescope reveals that it goes through phases, much like the Moon. Now, the planet's actual surface is not visible because it's surrounded by dense clouds that reflect about 70% of the sunlight that falls on them. It really kind of frustrates any efforts to study the underlying surface, even with cameras in orbit around the planet. Now, this ultraviolet image of light shows an upper atmosphere cloud structure that would be invisible at visible wavelengths. You also note, even with the ultraviolet, there is not even a glimpse of the planet's surface here. All we see is the clouds. Let's compare this to Mars now. Mars is much more tantalizing as seen through a telescope. The planet is distinctly red due to the presence of iron oxides in its soil. Now, the best resolution obtainable from a telescope's ground is about 100 kilometers, or about the same as what we can see on the Moon with the unaided eye. At this resolution, no hint of topographic structure can be detected, so no mountains, no valleys, not even impact craters. On the other hand, though, bright polar ice caps can be seen pretty easily, together with dusty surface markings that sometimes change in outline and intensity from season to season. Now, that begs the question about looking at life on other planets, and one of the most common ones we look at is Mars itself. For a few decades around the turn of the 20th century, some astronomers believed they saw evidence of intelligent civilizations on Mars. The controversy began in 1877 when Italian astronomer Giovanni Schiaparelli announced that he could see long, faint, straight lines on Mars that he called canal or channels. Now, in English-speaking countries, this term was mistakenly translated as canals, implying an artificial origin. The argument for a race of intelligent Martians, however, hinged on the reality of the canals, a matter that remained in serious dispute among astronomers. The canal markings were very difficult to decide, a glimpse only occasionally because of the atmospheric conditions caused the tiny image of Mars to shimmer in the telescope. And so if we, of course, put that on the back burner for a moment, we'll revisit Mars with a little more in-depth as we move further. Let's go ahead and look at the rotation of Venus and Mars. Astronomers have determined the rotation period of Mars with great accuracy by watching the motion of permanent surface markings. Its sidereal day is about 24 hours, 37 minutes, and 23 seconds. The rotational axis of Mars has a tilt of about 25 degrees, which is very similar to the tilt of Earth's axis. Mars also experiences seasons, very much like those on Earth. However, each season on Mars lasts 6 months. Since no surface detail can be seen through Venus's clouds, its rotation period can only be found by bouncing radar signals off the planet, and has been found to be 243 days. Furthermore, we have found that Venus spins backwards in a retrograde motion, and instead of rotating west to east, it rotates east to west, which means that we would observe the sun rising and setting on the opposite sides of what we would see here on Earth. And so let's just review a few basic properties of Venus and Mars. And you can see here we have our Venus and Mars as compared to Earth. So, for example, our semi-major axis, the period or the year that we would observe, the mass, and when we're comparing it to Earth, the diameter of each of the respective planets. You can see Venus is very similar in diameter to Earth. The density of this planets, again, Venus is actually very similar, again, to Earth. Even the surface gravity is pretty close, and escape velocity. So Venus actually has a lot more similarity to Earth than Mars does. However, one of the things you will notice is that Venus has a huge atmospheric pressure of 9 because, again, remember it has all those clouds that don't really let much pass through. So if we start looking at the atmospheric pressure of Venus, you can see it's huge, which is, of course, one of the big debilitating things if we want to do more exploration of Venus in comparison to Mars, which atmospheric pressure is very minuscule in comparison to that of Earth. And so those properties of Earth, Venus, and Mars are something we can kind of compare here. Venus, as we said, has a mass of 0.82 times the mass of Earth and almost identical density. The average amount of geological activity is actually almost as high as that what we see here on Earth. On the other hand, with the surface pressure nearly 100 times greater than ours, Venus' atmosphere is not at all like that of Earth. The surface of Venus is also remarkably hot, with a temperature of 730 Kelvin. Mars, by contrast, is relatively small, with a mass only about 0.11 times the mass of Earth and retains a very thin atmosphere. Mars is also large enough to have supported considerable geological activity in the distant past, and it probably had a thick atmosphere and even seas of liquid water.